have more people joining. I think we can kick it off. Hi, everybody. Thanks for joining our webinar, Robo Radio 12. It's our monthly webinar where we discuss topics in design, user experience, and robotics and automation. We're happy to have Brian Ringley, Distinguished Product Manager and HRI Designer at Boston Dynamics. Um, Brian, thank you so much for coming, sharing your knowledge, personal path. I'll give the mic to you and let you start.
Yeah, thank you so much for having me here today. So let me take a long sip of tea here. I, I actually I didn't really prepare any visuals for this. Although I might show a few things from a recent talk I gave at Harvard XR. Shakir, I totally forgot that there was a presentation aspect to this. I like thought that this was
All
just a
good.
podcast interview. I was like, oh, wait a minute.
Oh, don't worry. It's okay. If you want to keep it freestyle, like conversation format, totally fine. Robert is very sort of freestyle format talks. Do you want to turn it into conversations? Because we prepped a bunch of questions for you.
Yeah, there maybe
This will go live though. Yeah,
this is
yeah.
like classic. Yeah, I'm like, I was like totally coming in with like interview mindset, going over the interview questions and like did not like
I love that. I love that. No, no, I think it's
I could
cool.
like scramble right now and try to like find some imagery, but I'm not sure that
No,
that
no,
would
don't worry. It's
yeah.
totally fine. Well, the first question. Um, when w I think we saw you as one of the speakers on Figma Config, and we're like, oh, that's amazing. Traditional sort of UX um, or product design community starts looking at designers in robotics and automation field. That's amazing. And we saw your name and wanted to invite you to Robo Radio. And when we started looking kind of deeper into your career path, we noticed how you started in architecture and then shifted your career towards product management and then more towards HRI. Um, how do you keep flowing like that? Like, because a lot of people we know in the industry, they're like, "This is my craft. I just stick to that."
Right. Yeah. And I'm not, yeah, I get a lot of questions about um how did you get into robotics? Especially from young people who are like still in school. How did you prepare for this? I'd love to have a career like that. And you know, I I just don't think that, at least for me, right, everything's just from my limited point of view, that a career isn't something that you can really plan for in that way. My experience was that I just wanted to be an architect. I just wanted to be a traditional designer. I had always been attracted to technology. I thought that that was just an inherent part of the job. And then when I graduated, it was the global economic recession. So I had to like backpedal a little bit. And I was like, well, I really like technology and I'm in this university environment. Maybe I can, make a job for myself in the fabrication lab. So, next thing I know, I'm spending, 40 hours a week doing CNC machining and programming and being exposed to all sorts of other technologies that are, similar, like 3D printing and laser cutting. So I really started cutting my teeth on the digital fabrication side of things. And simultaneously, because when you're young, you hustle, started picking up a little bit of teaching work because I'm like, well, the students are also interested in learning these types of technologies. At the time, it wasn't fully integrated into the architecture curriculum, which is where I had just graduated. So I said, what if we taught classes in these technologies? And then as I started teaching, technologies started emerging, like scripting, like parametric design plugins like Grasshopper, making that sort of thing more accessible. So some of my peers started talking about, oh, it really seems like you could leverage these technologies to teach fabrication. And this is where I think Branko Kolarevic came up with this term, but this is where like the notion of computational fabrication came into play, which is like what are the affordances of computation and specifically like parametric software systems for manufacturing. But it's also just more broadly like the concept of design for manufacturing, but you're like leveraging analysis and parametric design tools to kind of optimize that process. So the pedagogical exercise just became how do we develop a really deep understanding of a manufacturing process, even though it's simplified, right? You know, we'll say like one type of machine because it's an academic exercise, but understand that really deeply. What are the affordances of that in introducing complexity, introducing aesthetics, introducing performance even into your designs, but then driving that and measuring that through the parametric tools. And that's really where a lot of kind of thinking around design ecologies came into play too, right? Like as a designer, you're an agent in an environment. And this particular environment has materials. Materials have particular affordances. You know, I always loved like Baltic birch plywood. Like, let's think about the plies as an expression of depth because we're using subtractive manufacturing. And then over here, you have a particular type of manufacturing, like CNC machining. You're typically using ball mills. You know, what is the geometry of the end mill? What does that mean when it comes into contact? You know, so a lot of the conversation was like, yeah, you could explicitly model something like the plies of the plywood after they've been milled and have the fluting of a ball mill, but that would be insane. Why don't you let the intelligence of the material emerge and the intelligence of the manufacturing process emerge and kind of combine both of those things?
Gotcha. I think we should dedicate a separate portion of this webinar to materials, how they affect robotics. Maybe you have an opinion about what sort of materials should be used for humanoid robotics when it comes to human robot interaction.
And the materials to actually make the robot with.
Yeah.
You know, it's so funny because I've spent all of my career thinking about the things that the tool makes. And the thing about the humanoid robot is it kind of gets fetishized as an object. Like that robot is the tool, and everybody, you know, talk about the industrial design of the robot. So there's this funny thing where instead of like what materials are good at being manipulated by a robot, which theoretically anything, we kind of end up talking about the robot itself and what it's made out of. But I mean, in terms of the way we think about materials for robots, I mean, there's a lot going on inside of a robot materially. But like the two things that I think I'm most conscious of in terms of like how you experience a robot is its presence. A lot of the presence of machines like this are the noise they make. There's kind of the size, right? It's the thing that's kind of weird about a humanoid is, you know, Atlas is like basically my size. It's weird to be face to face with a machine that's that capable. So there's that piece of it too. But then there's like the noise. And when I think of like the experience of Spot, like the quadruped robot, I think of the stomping with the feet. I think of the motor noises, and I also, more particularly, I think of like the cooling fans. So one thing that's really cool about Atlas in terms of how you kind of coexist in a space with that robot is that it's completely passively cooled. So we basically created a bunch of heat sinks by creating fins all along its aluminum structural parts. And that allows heat to just dissipate naturally without the need to introduce fans. And that's good because that's a reliability thing as well. Like the more moving parts you have,
Hmm.
you know, the more likely something's going to break and need servicing. So you're just like removing that complexity from the robot. But it
Hmm.
also means that when you're in the presence of that robot, you're not overwhelmed by the noise that the robot's making. And I think it's not that that many people have been around humanoids or large robots like this necessarily, but like I think an experience of being in a factory and being around machines like this in general is one where like the noise is the thing you
Hmm.
experience first and foremost. And then there's kind of the padding, right? There's the exterior. There's a whole conversation about color,
Hmm.
about surface treatment. You know, our goal with Alice in particular was to make it, we obviously didn't want it to be terrifying, but we want the user to understand that it's an industrial tool and from a
Hmm.
safety perspective, kind of treat it with the respect that you would treat like an industrial robotic arm. For instance, you want to go up and hug a metal industrial robotic arm. We certainly don't want you to hug Atlas. That's not a good idea.
Hmm.
So, we tried to come up with a kind of set of color blocking that we thought represented our brand and kind of gave it like an approachability standpoint.
Hmm.
We gave it a head, and there's a little bit of familiarity and friendliness when a machine has a head, when a machine can look at you. But we didn't overdo it. We didn't try to make it look like a human head.
Hmm.
Um, so there's the kind of material, and it's like a little bit of a softer material. You try to make that legible. Like if for some reason, the padding on the exterior robot, like it's not like all steel, like a Terminator type look. So there's kind of a soft padding, there's soft color blocking. So we think that that's part of like the HRI bit of it. And then like beyond materials, there's also the way that the joints work. So I think one of the distinctive things about Atlas is that it's all offset joints. And when you do those offset joints, where you have like upper leg and then lower leg, and they kind of rotate like this, and they're offset to the side rather than being in line, is
Hmm.
that allows you to completely seal the joint between those two links and eliminate any pinch points. So it's this interesting game of like friendliness and approachability, but also having like a respect for the fact that this is an industrial machine. And I think been one of like the driving design challenges. And there are other dimensions to it as well. I mean, we want this to read as a high quality product. We think that
Hmm.
part of our differentiation is that even though there are many, many companies out there making humanoids, we make the best machines, the highest quality machines. We have the best craft. They're the most manufacturable. They're the most serviceable. They're the most modular. So again, that design for manufacturing mentality and the fact that we've been through the commercialization process with Spot, shows that maturity at the product level relative to the competitors.
Gotcha. Um, let's talk a little bit about your personal challenges when you were shifting your career chapters. Like one of the things for our design team, but also like last time we had Jason Klein from Humanoid, is designing for unpredictability. Like you probably know from your experience for any other products, the user flow when we design it is quite linear. Like here's step one, step two, step three, and you sort of can predict that workflow. When it comes to humanoids, we noticed like the one of the challenges, like it's never linear workflow. It can go sideways, multiple branches. What in your career it was a challenge designing for HRI?
Yeah, I mean, it's interesting because when I first started with Spot, people were always talking about either like notions of cobotics or HRI or interaction with the robot. And things is I'm like, well, the robot is kind of supposed to be this invisible means to an end. Like these types of industrial robots, like you're not petting them, you're not like riding on top of them, you're not doing work directly side by side with them. Like they're off doing their own thing autonomously in service to, like in the case of Spot, like industrial inspection or construction management through automated reality capture. So it was like for me, like the game of HRI is to make people forget that there are robots. Like robots are this kind of invisible, like physical background process that, do the things that you care about them doing that achieve your business goals. But your interface with the robots is a piece of software. And that piece of software only has to tell you about the robot in as much as the robot's unpredictable or doesn't work well. If the robot's just doing what the robot's supposed to do, then all you care about, like for example, in the case of industrial inspection, is that your factory is running well. So you have this window, but this window is about your factory health. But the best way to get that information happens to be through physical robots. So like my kind of weird dream as a designer is that I don't really have to design that much because these things are kind of running invisibly. Now, in practice, that's not necessarily true because these are all like human purposed environments and there are people in these environments doing other work. So when Spot's walking around a factory, it often has to negotiate its way around workers and other robots. So you do end up having to think about those things and how do you create predictability. With Spot, we rely a lot on like sound and lighting. Spot doesn't have a head it can articulate, so it can stop and it can point its body. And we've kind of created some behaviors, like for example, if Spot needs to cross through a really busy kind of intersection where there might be other robots or people or forklifts, its body will kind of do a full turn to the left and a full turn to the right. Now, does it really need to do that with its field of view and its cameras and its 360-degree perception to know if something's coming? I mean, not really. There might be reasons if other sensors are on it to do that. Really, it's about that expressiveness communicates to people like, oh, I know from that body language that the robot is pausing and looking both ways before it crosses the street essentially. So one of the nice things about Atlas is it has a couple degrees of freedom in the neck. So it can actually look around. So oh, the robot is looking for the next part that it's going to grab. Oh, it's looking for a place to put that part in some kind of materials handling application or automotive sequencing, as we've shown in some of our videos. So you kind of I think the head gives a lot. I think it can't be underestimated how much like the addition of a head that can be articulated and look around kind of lends to the predictability of what the robot does. But I think you still need to, layer software interfaces on top of that. Um it's not really a robot you're gonna be like standing there and like staring at while it does. No one watches their Roomba vacuum, maybe like the first couple times and then the novelty wears off. So the idea is that they're going to be interfaces, either Boston Dynamics interfaces, or we're going to have APIs that, hook into pre-existing factory interfaces. And that's going to be giving people in some kind of remote office the information and the, telemetry that they care about. In which case the HRI goes back to software UX. So I've adopted my latest designer title is interaction designer, kind of like straddling between HRI concepts, which I think are traditionally conceived of as like a physical interaction in space between a person and a robot and all the kind of signs and signifiers you use there to kind of communicate intent. But then just back to pure like UI UX, which is to say, well, if a lot of these robots are autonomous and remote and they're being monitored from like a central control room, then the software is actually the primary way that you interact with these machines. So it's all very much mixed up. It's very hard, I think, to disentangle like software design concerns from hardware design concerns.
Gotcha. Do you see personally in the kind of next 5 years that balance will shift? Well, like, would you want to see a world where software sort of presence in this interaction experience diminished to 10% and then there is more like sort of screen agnostic, or you feel like, oh, that's actually really unrealistic?
Yeah, it seems for me like the measure of success is that there's just less stuff. Like you just don't need like as many interfaces to do things. Just because the way that you communicate with the robot is like so much more natural. Um, if you think once one of the measuring sticks, it's strange, right? Because these robots learn now. A robot like Atlas like learns rather than being kind of trained or told what to do. So you kind of think about, well, what is my basis for that, right? I don't really have a lot of precedent for like teaching a machine what to do. Like all machines that I've ever dealt with have been explicitly programmed in one way or another. And now I have to teach something. And well, the way that we're building up these behavior models is through behavior cloning, also known as learning from demonstration. We're using these VR teleop systems. We're like basically suiting up and performing these tasks and building up these action data sets so that the robot can start to correlate basically the pixels it sees in its perception to the appropriate like motor actuation to do like the next action. It's this game of like, what is the statistically likely next movement I should take based on what I'm seeing at any given moment. And then that manifests itself as autonomous behavior from our perspective, even though that's not quite what's going on, but functionally it is.
Mm-hmm.
Um, so if you like take that and you say, well, okay, do I really want an end user to like suit up in like a full like VR suit with body trackers every time they want to teach the robot? Like, I don't do that for training people. When I train people, I do demonstrate with my body often. I talk to them. So you do, it does kind of shift you, I'm talking, oh, my goal is like, make the robot disappear and like everything is kind of mediated through a software interface. But then when you think about it that way, what is the most natural way for people is if that's the model to like the natural way for people to communicate with each other and apply that to robots, you end up pulled back into a physical space. And you could say, okay, so is it really just about me standing in front of a robot and having a conversation with a robot and demonstrating with my body language? But there are other ways to think about it too. I mean, there could be a future where, we can just scrape YouTube and basically every second of video, every frame of video where there's a human body performing some kind of action or task in an environment can feed into a large behavior model. That kind of becomes like a chat GPT moment for generalized behavior. So, the need for someone to explicitly demonstrate something new is less. And if you needed to do it, and any video would suffice, I mean, you could just kind of do a selfie video and you could text that to the robot. Or you could just be on a video call with a robot. So again, so then it brings you back to the remote thing. So it's it's completely new ways of interacting with like tools and agents in our environment that have just never existed before. So it really feels like completely blue ocean in terms of like HRI and UX principles in general. And I think that's why I've like encouraged a lot of people who are starting their career and they want to be designers and get in this field. I'm like, well, I think, you know, there's a lot of this and that about how you need to be kind of an engineering type or you need to kind of be a coder to get into robotics, but there's like so much space for creative people to come in because that's actually a really hard problem for engineers is like envisioning the future, thinking about these new ways of teaching machines and interacting with these things to achieve our goals. So there's a pretty wide open space right now.
Mm-hmm. Gotcha. Thank you. Anyone in the room has questions? I'll let you guys ask.
Yeah, I mean, speaking about the robot behavior right now, like what is one thing you probably change to make this industrial robot feel more comfortable around you?
One thing I changed to make,
Yeah.
yeah. It's an interesting question because I don't the question kind of says that people don't feel comfortable around the robot, and the question also assumes that you should be around the robot. And I think that's all in play. Like how close to the robot do you really need to be? I mean, we've seen this evolution with industrial robotic arms moving to cobotics, which is just over time for certain tasks that don't require a lot of like force and payload, they're able to kind of create these machines that are like inherently safe. Like if they run into you, they'll sense that force and they'll stop, and you can touch them and you can pose them. And it's an interesting concept. I don't know if it quite works for machines that are balancing on legs. And also that's not the way that you program a humanoid. So I think it comes back to how you feel in the presence of a robot. Like, what's the right size? If it's too big and it's too hulking, if it's shaped in a sharp or angular way, if the materials seem too severe or sharp. But I think there's also the notion of character development. Like, do you want the robot to have a personality? If it's just an industrial tool, do you care if it has a voice? Do you care if it has body language that's kind of unique and particular to a single robot. And maybe you do. Maybe that is something that lends approachability, is that, we have these like robot factory worker characters that you can essentially engage that kind of, I don't want to say have personalities because that kind of implies something I don't necessarily want to imply, but it just gives like, it's just a little bit more fun. And it just makes the experience a little bit more perhaps lighthearted, even though the robot's still doing serious work. So I think that that's something that our design team is thinking a lot about, because we've used Spot, at least in a lot of different like entertainment contexts, where it's like dancing, or it's a character at an amusement park, or it's on television playing a character. And it seems like, especially with a lot of the various like behavior models out there, and there are these like large language models that are like also voice models that are trained on people's voices, that are able to kind of bring in like nuance, like knowing when to laugh at a joke, or kind of like interpreting sarcasm. Um, so again, I think like it's been a little bit nice and convenient for me to have this like pretty small constrained box around industrial applications. Because if we were talking about, for say, like a humanoid that like lives in your house with you, it's like completely, completely different. And I saw a lot of that at CES this year. A lot of companies kind of saying like this robot's going to like be in your home and take care of you. But it was also like, what exactly is it doing? Because a lot of the examples and a lot of the like demonstrations were very bizarre. Like there was like a robot that says good morning to you when you like first wake up. And I'm like, first of all, is that the first thing I want to see when I open my eyes? Second of all, that means that the robot was like watching me sleep, which is like also very strange. And then there were things like the robot was like serving food to a family, and like, the mother was like, "Oh, how did you know that I love almond milk?" or whatever case. It's like, because you bought it and put it in the fridge. Like the robot like didn't grocery shop for you and like understand your needs and kind of invent something. So I think that that space is a little funny. Like people are really still, because like how well do any home robots work? I mean, outside of like the Roomba and all the various robot vacuums and cleaners, which you could still argue don't work perfectly, probably you're still going to do a better job vacuuming yourself. So there's kind of this weird state where it's like, are robots useful enough to introduce them into that environment? And then even if they were, what exactly is it that they're doing that's worth having a machine like that in your home with you?
Yeah. Speaking about personality, at what point do you think robots should have one?
Yeah, it's kind of why I like the term character rather than personality. I think
Mhm.
personality implies more like agency and something like very human that's particular to a person. I think character puts us back into the realm of fiction, where we understand that this is a synthetic layer that we're putting on there for the purposes
Mhm.
of entertainment or the purposes of product design. An example that we have at Boston Dynamics is we've got like a tour guide character that we've essentially uploaded onto a spot because we have a museum, of robots. So you can basically have a conversation with this robot, and you can ask it about, or it'll ask you what you want to see next, and blah blah blah. And it's like, it wouldn't be a very fun like tour experience if the robot were just like super monotone and robotic, right? If you want it to create an engaging experience for people coming through and learning, it's basically, it's a new layer of interaction design for like this museum experience, where instead of seeing a video or doing an audio tour or reading off of a placard, you actually have this character that walks around and talks to you. So yeah, you want to give it like personality to make that experience entertaining. And I think that's where like authenticity and like honesty in robot design comes into play, which is like you can kind of come up with a pretty good rationale why the robot has a character. and why the robot might exhibit certain characteristics that we typically associate with people. Um, because you can get pretty disingenuous pretty quickly. Like I don't, I'm very open-minded about where robots are going and the nature of human intelligence versus robot intelligence. I think there's, endless ethical and philosophical and intellectual debates to have about that. And I think ultimately those are good conversations to have because it keeps us thinking about what it means to be us, to be human. I think that's kind of the real joy of robotics is it pushes you into that space. But I don't really see a lot of value in tricking people, or in implying that robots are capable of more than they really are, or of genuinely trying to fool you into thinking that a robot is a person.
Thank you. Any other questions?
Yeah, I think my question based on sarcasm. I have a question. Can the robot detect and understand sarcasm right now, or maybe in the nearest future, they can do this more human things? They can understand sarcasm.
Yeah, I mean, a lot of that robot character stuff, they're just running off of large language models, and a sufficiently complex large language model is not always able to pick up on sarcasm, and certainly not able to pick up on all like the inside jokes and ironic nuance and all that sort of thing, or like British humor versus American humor. Um, all those sorts of things. But like, yeah, like in principle, the large language model is able to pick up on things like sarcasm. It's able to tell when you're telling a joke, and it's able to kind of respond in kind, at least based on the patterns of statistically likely responses it's seen in the past. I think maybe the more interesting question is like, would it ever like truly surprise you with its response? And you see a lot of those like articles like, oh, the chatbot fell in love with me, or I fell in love with it, or I thought it was sentient, or it told me it was sentient. But like you can almost always look at those things rationally, or I would argue you can always, at least to the extent of my experience, look at those things rationally and kind of track that back to, well, yeah, with enough kind of demonstration of language, it's seen those types of conversations before, and it's simply kind of playing those things out. And then you kind of cross that fuzzy line where if it's able to do that like perfectly, like how different is that than the way we communicate? But I think the thing to watch out for is its capacity for novelty and creativity. We all, to a large extent, like as creatives, obviously that doesn't come out of nowhere. That comes from your experience and your kind of interpretation of all the, data and other experiences you've had in your life. And if you're an author, you're influenced by your favorite writers. And if you're a visual artist, you're influenced by your favorite sculptors or painters. So there's a little bit of that, but I haven't seen anything where I'm like truly taken by surprise in kind of some novel way, the way that I am by creative people, by funny people. Um, so I think when we get into that realm, I'm still a little skeptical of what these models are capable of, but I want to remain open-minded because I think it would be foolish to draw any kind of line in the sand. I mean, there's just like the larger question of like, is there anything that a robot couldn't eventually do? And I think it would be like naive to say that there is anything that the robot couldn't eventually do. But I also think it would be equally naive to assume that it could do anything in the next 20 years, right? Like it's just a question of like, given enough time and like societal stability and investment in technology, is there a limit? We don't know. There's never really been a limit to, the kind of capacity of human imagination to invent these things. So we'll see. I don't like to take too hard of a stance either way, but I also think that to like bring it down to a more like humble point, how many well, of all these humanoids out in the world, how many of them look like they're doing anything useful? I don't think we're there yet, right? So despite all the hype, all the investment, Despite how incredible some of these models are, particularly like looking at things like Claude Code, you know, when we get to embodied AI and physical robots, like how many examples out there of this new breed of humanoid robot actually achieving business goals, creating real value, generating profit, being worth paying quite a bit of money for. It's hard. There's a lot of hard work to translate some of the things that have become kind of successful in the purely software space to the physical world.
Yeah, you're right. And yeah, one more question.
Yeah.
Another question, when the robot goes outside the lab to the real world and interact with human, what was the some unusual thing that you and your team like understand when robots firstly go outside the lab?
Yeah, I mean, a lot of it has to do with a limited amount of data. So, for example, if we're talking about generating robot behavior from behavior cloning, if we've done a model and the robot's only ever seen the setup in our lab, even if it's a very similar setup in a factory, there are going to be some, qualitative differences, and that might be enough for the robot to not be able to complete the work adequately or to exhibit less grace while it does it or to not do it in as optimal of a way. So then you kind of supplement that data. So the thinking is just like with language models, the more data, the more the robot can generalize so that when it does move outside of the lab, there's just less stuff that's like out of distribution and it's able to adapt. So I think its behavior, its affordances or its capabilities in terms of behavior are limited by good hardware, which I think we can deal with, and are limited by data, which we are currently, dealing with. Um, so for me, the harder question is how do you author behavior? Because the robot doesn't have any innate desire. It doesn't like wake up in a factory and look around and know, and it's like, I want to be productive in this environment. Like it needs a human running a business to give it like goals and objectives and to have it adhere to a particular like method of doing work and to kind of understand metrics for success. So to me, that's the more interesting space. It's just a matter of time to build up the behavior capabilities, but to be able to communicate to the robot exactly what you want it to do in a very like repeatable manner. And also equally as important to have it be able to communicate that it has done that work. So these are like a lot of these models are very black box. So is there a way for the robot to like communicate that it has done the job successfully other than just observing it? Like these are all like much trickier problems than generating the behavior itself. Is basically like commanding the behavior, interpreting and measuring the behavior. And these are also stochastic models, meaning that they change slightly every time. Just like if you repeatedly ask the same question to like a chat GPT, you're going to get different answers, slightly different answers over time. Or if you keep generating the same image, it mutates slightly. It's the same thing with the action space with something like Atlas in a behavior model. But you don't really want that. So you want all of the affordances of like generalized capability, which come from these like statistical methods like behavior models. But you also want the old way of things where like once you program a robot, like a robotic arm, it just does the exact same thing every time, super predictable. So you're trying to, I think the real hard work is like bringing those two worlds together where I have all the benefits of behavior cloning, and just generative AI models at large to basically instruct the robot to do anything, but then to have it perform it in a very precise and repeatable way and to communicate how well it's doing it. That's the best of both worlds.
Sounds like impossible.
I also have like a question about like, have you ever felt that robot scared you? Or for example, you felt uncomfortable with it I don't know.
Um, let's see. I mean, I think I've had a few moments like when you're really standing face to face with something like Atlas, or at safe distance, like particularly when you're doing like the behavior cloning work and you're kind of in the same space with it, it definitely has an imposing presence. And if it stumbles and catches itself, your heart might skip a beat if you're too close to it. So I have those moments of like, again, like with any other industrial machinery where like you really kind of learn to respect the machine, follow the safety protocol. Um, there's anything like behavior wise, right? Like the robot only does what we tell it to do, and often poorly at that, right? Like, these things don't invent behaviors, and we don't quite have data on the scale where you're getting this like hallucinatory stuff where the robot gets confused and does the wrong action. So everything's very like bounded, and the robot is only going to do some version of the exact thing that you've demonstrated to that robot. It's simply not capable of doing anything else. The math just doesn't work. So no, I haven't seen anything like sci-fi in that respect. I mean, and in terms of maybe not fear, but awe. I mean, I have seen that with some of the Claude code stuff. Nothing that's like, oh my God, you're alive. It's just the kind of awe and wonderment at how effective it is at actually building working software, at interpreting, and particularly, the building software part isn't as interesting to me as the ability of like a Claude model to receive instructions from you, build a plan, explain its plan to you. So this kind of ability for the model to understand what it's doing and communicate that back to the user, that's the thing that I'm really after kind of in the physical robot space. That's the thing that I find like truly awe-inspiring, is like this thing can really analyze its plan of action. And it also becomes a teacher in that way, which I think is really cool. I'm not a great coder by any means. So I often kind of say, well, thanks for building this thing for me, but like I'm flying blind here. Can you kind of teach me about it a little bit? So, in that process of working with these tools, still growing myself, right? Still being interested in learning, I think is a really important part of interacting with these systems, in a healthy way.
Yeah, that's true. And what about maybe, do you know or can name some standard patterns that is there in the human robotics interactions already? For example, as we have in our user interfaces with loaders, for example, like every user expecting that it will be like, for example, progress bar, something maybe in the robotics as well that you can already name?
Yeah. Yeah. And I would say like, no, there probably isn't a hard set of standards yet. And again, I think that's part of the like, blue ocean that I was talking about earlier, where there's just like a lot of space to play with those sort of things. But at the same time, I think gesture, gaze, and lighting and sound, these are tools that have been kind of repeatedly deployed. So, the robot's body is expressive. So there's the ability for it to, if a robot did something like this and, don't approach me or something like that, or the robot waved and it's just acknowledging your presence and you understand that it's detected you. And then if you don't want to move the robot in superfluous ways, we also have the light ring and, various lighting elements, and, red is usually bad. So, like maybe that's not the right time to get close to this robot. So we can use those things to kind of indicate, is the robot safe to approach? Is the robot currently being teleoperated, or is it currently in autonomous mode? You can kind of develop a language for that. I always talk a lot about car signals as being a really interesting thing to learn from. We've talked about this in the context of like quadrupeds too, which are a little bit more vehicular in their morphology, which is like, why don't we just use like all the same patterns that people use while driving their cars? Because that's a language that a lot of people speak. But then, you have sound effects like beeping to let you know that like something's backing up. You have natural language where the robot could actually just be communicating with you. And then there's the gaze that I talked about earlier. Like, the robot could be looking at you to acknowledge you. It could be looking at the work to indicate the next thing it's going to do to kind of lend predictability. But I wouldn't say that we're kind of to that moment where we're at the level of like mobile devices where there's like a whole language around like gesture and touch and swiping, long holds versus short presses. I think that that stuff is kind of still being invented. I think the same is largely true like in the XR space as well. I don't think it was really until Meta like did their very, very hard push into like social VR, with like Horizons and stuff that like a lot of that stuff really did get kind of codified by like a group of designers who spent a lot of serious time thinking about it. And I know there's a lot of like talk right now about, oh, Meta's like stepping away from XR and this, that, and the other. But nevertheless, I think the people that have worked there over the last, gosh, 5 to 10 years have really helped kind of create those types of standards. So I expect like with all the activity going on with robotics and human robot interaction with humanoids, that maybe some of that stuff will start to cement in place. And design teams like the one that I'm on can also publish stuff about that. Like, this is what really works well for us. This is our set of design standards. What's like a design system like when you kind of extend that to HRI? I just don't think that there's a huge amount of precedent. Not to dismiss all the experts out there. Like, people have been thinking about human robot interaction at places like MIT since before I was born. Obviously, like there's a lot of thinking about this, but like in terms of it being cemented into products as like a shared language that we all know, I don't think we're there yet.
That's amazing. Thank you.
Any other questions?
Yes. Oh, go ahead. Sorry.
Okay. Yeah, we talk a lot about like AI, automation, and everything like that. And I'm really curious, like, what part of your work routine is still manual or like messy, or maybe you still enjoy do it like manually?
Yeah. I've always thought about tedium as a really important part of kind of like honing a craft. Like when I was an architecture student, it was still, I'm not like so old, but like we didn't all have like laser cutters and 3D printers the way like students would now. Like those things existed, they just weren't as accessible. So if I was putting like wood flooring in my architectural model, I was etching every single joint between the floorboards with a knife. And, I would just be in studio for like hours and hours and hours, just like carving every individual detail. If there were shingles, I was making every individual shingle, really trying to like capture the detail and tectonics. And like, do you need to do that forever? Like, no, not necessarily. There's nothing wrong with using technology to automate that stuff. But it was a way for, we are primates that have evolved over millions of years so far as we know, right? So, and a lot of that evolution is just like walking and talking and taking things slow and letting our brains cook. And I think there's just a lot of like other stuff that goes on up here that can really only be activated by that tedium. So I think it's valuable to an extent. And then then I started teaching in architecture and everyone just like laser etches everything. And I've always been, this is like slightly beside the point, but it's always been a little bit disappointing to see the use of like the laser cutter. And then when they present the finished model, you just see like the burn marks everywhere. And it's like, well, if you have this amazing gift of automation, either figure out how to do that doesn't leave the burn marks with the technology, or you have to have a manual finishing process. Like, the technology got you 90% of the way there. You need to take that other 10%, the 10%. And I'm like, it's such a kind of like, old man shaking his fist at the younger students. But I always thought of it like the way I think of escalators. You can get on escalators and you can just stand still and you'll achieve your objective of like getting upstairs. But you can go so much faster if you still walk and use the escalators. So when you're using these tools, like, I think always thinking about the ways that like your human intelligence combines with that. So like, I mean, back to the topic of like, TDM or manual work, this comes up a lot with things like in the evaluation of like Claude Design, which was released, I think, just last month. versus something like Figma. And like you can have a conversation with Claude Design and you can generate a lot of stuff really quickly. So there's kind of that value there of that like first draft, the big idea, getting a bunch of stuff like on the page, so to speak. But it would be horrible if you wanted the level of quality, or at least the level of quality that like I would expect from our team in like design mocks and something like Figma, to like coax that out of a language model. It would just be a terrible way of working. You would just be over and over again, like spending tokens, trying to refine and do the details. And it's like, I just want to get my hands on it. Like I know how to do it. And using these tools can also be pleasurable. Like working can be nice. Using your body, using your hands, using your mind can be nice. So I think it probably boils down to each individual's personality. But I think for me, the takeaway here is thinking critically about the things you want to do versus the things you want the technology to do for you. How do you want to spend your, precious time here on Earth? Like what makes you happy? I think the complication of that and kind of the corporate setting is that there is a lot of pressure to use AI to kind of automate, to go faster. But at the end of the day, that's that's just about the mundane stuff. Like my use of those AI tools isn't going to create any kind of HRI breakthrough. Like at least I'm very skeptical of that. Like that is going to come from human designers doing tedious manual thinking. Um, and and I think you see a lot of that when you talk to people who are kind of who have been in the creative industry for a long time. And also most things just aren't that good, right? In the world of design, we aspire to that upper 1% at all times, and we rarely get there. The point of good design is its rarity, that it's hard to do, that it's difficult to achieve. So you're probably not going to get that from these models, which are essentially tuned to median performance, like statistically across the board. Um, so I think it's fine. I think like we'll continue to use these tools. They'll have incredible benefit to letting non-experts do capable work in fields of like coding and graphic design and things like that for the little things. But when you really want to do something special and meaningful, it probably doesn't have a place and you'll still want to do that manual work. And also, I like doing manual work.
Thanks. I totally agree.
Anyone else? We have about 5 minutes.
Yeah, I was waiting. Okay, so more like a personal question. So I saw a lot of people now making custom tech on the internet, like little custom computer or like whatever, like robot and etc. Do you think it's gonna really affect the industry somehow, or it's more like high level trend or something?
You just mean like in general, like the kind of the
Yeah,
ability for makers to
yeah, because
do
now
skills.
it's
Yeah.
way more accessible than it was before.
Yeah. I mean, I think it's a lot of fun. First and foremost, it's a lot of fun. Like I can speak for myself that I have a lot of like projects I never got to because there weren't enough hours in the day, and things like Claude might be a shortcut. So for example, oh, I always wanted to make my own whatever, like CNC machining software, and now Claude can help me do that faster. Because the point of doing that was because I wanted to make certain types of objects with that machine. So I can get to the I can get to the thing faster. If the point of that was that I just want to learn to code and I love coding and I love thinking about software, well, I should probably just do it myself. So I think it will allow hobbyists to, and I've seen it. Like I've seen people who have made their own like XR gloves for like motion capture, people making their own quadruped robot. Like you can really do some like amazing things on your own. And I'm sure that we'll see entrepreneurship come of that out of that. We always have. I mean, the personal computer and every invention opens up more people to kind of use those tools to come up with more ideas. So yeah, I think it will have a pretty big impact on the nature of entrepreneurship. It's a lot of these AI tools, though, are very expensive and very like they consume a lot of energy. So there are these other limits that could potentially, hold it back.
Mm,
With frankly to do really incredible things with some of these AI models is probably too expensive for someone who's just doing something recreational. So there's a little bit of gap there that might slow that sort of phenomenon down. But yeah, I mean, I think if you go back to like, Chris Anderson's book on makers, I should actually reach out to him. Like it'd be really interesting to be like, what would that book look like now with kind of the ability, like, I could make my own flying drone. That's crazy. That's, it's totally crazy to think of like I had a, very quaint childhood with no internet, and now I could just make my own flying robot in my free time if that's how I wanted to spend my time.
yeah, okay, thank you.
Mm. All right. Maybe last question, Brian. Let's kind of make it more reflective. In this hour, you showed a lot of open-mindedness about so many topics in robotics, cultural, philosophical, technical topics, design topics. And looking back, can you name one thing that maybe in 2 or 3 years you're really not going to change your opinion about?
I'm trying to think of
Yeah.
what have been. In my old Twitter days, I was really, really opinionated about robot bricklaying systems.
Okay.
I had this whole thing where I was like, I don't think like 3D printing a house out of concrete makes sense for mostly for ecological reasons and modularity reasons and the ability to reuse the space. And I was like, and I don't think using bricks, having a robot stack bricks makes sense because they're tiny. Like masonry comes from the ability that it's like a human hand laying that thing. And I remember Fast Brick Robotics is like an Australian company came out with a robot, this was years ago. It's still active and it lays CMU, concrete masonry units. And it's basically like a giant Pez dispenser arm that like it drops those things. And I'm actually reading this book right now called Sam, which is the name of the original bricklaying robot by the company that's called Construction Robotics. So a journalist wrote a book about their kind of struggle to make a new product. And I'm reading this book and I'm like, I wonder what they're doing now. And sure enough, they're also doing concrete masonry units. So one opinion, this is like a totally random thing, but my opinion that I'll like never be open-minded about is that bricklaying makes sense for robots. That like once change is always a two-step process, right? Like you're like, I'm going to do the thing exactly like a human did, but with a machine. And then once you realize the affordances of that machine, your approach to materials evolves and there's a better way to do things. And also, a handmade brick wall, it's like buying vinyl. It's like, I want that look.
Yeah.
I want that manual labor. That's like a labor premium I'm paying to have a particular look that this was like laid down by human hands. It's, vinyl just sounds better. Like hand laid brick just like looks better, as a particular feel. If you want industrialized facades, then get an industrialized facade and approach it differently. So that's like an extremely kind of out of left field, probably opinion. But like since I come out of architecture and construction, that's something that I was always extremely opinionated about.
Nice. That's amazing. Okay. Thank you so much, Brian, for coming to Robo Radio. This was very delightful, deep conversation. And yeah, would love to have you on again or visit our office.
Yeah, maybe next time I'll have
Yeah.
some slides prepared, but hey, at least we had more time
Yeah, yeah.
to have
Yes, let's
conversation.
do it. Thank you. Thanks, everybody. Have a good day.